All right, so first we want to find mod z, but without finding z itself. So mod z, just remember, oops, let me get rid of that. So mod z is the same as mod z1 on z2, and we know from our properties that we can break that up. So we just want the modulus, the length of z1 and the length of z2. If you think of z1, of course, it's a cross 1 up 5. So to find the length, we're just using Pythag, or just remember the formula. So we're doing 1 squared plus 5 squared and square rooting that. And then Z2, we've got 3 squared and 2 squared. So what have we got? We've got 25, 26, 26. And on the bottom, we've got 9 and 4. So we've got our 13. And 26 on 13 is 2. So we've got root 2. So I couldn't fit it in. So I'm just going to write next to here that is root 2. So the length of our z is root 2. So that's handy to know for later. Let's get rid of that. Delete, delete, delete. Okay, oops. And there is some more. Some more. So the next part, sure, we have to use, oops, come on, there we go. We have to use that here. Okay, so find tan of inverse tan of 5 minus inverse tan of 2/3, and hence find arg z without finding z again. Okay, so again, we're using, so if you remember tan, oh, sorry about the writing, a minus b, it's on your formula sheet. I'll do it underneath, sorry. Tan a minus b is tan A minus tan B on 1 plus tan A tan B. So we can use that here because we've got tan A minus B here. Right, so our A, we're letting our A be inverse tan 5 and our B be inverse tan 2/3. So if we write that out using the formula, we've got tan of our A, which is inverse tan 5, minus tan of our B, which is inverse tan 2/3, all on 1 plus tan of, sorry, this is getting messy, inverse tan 5 times tan of inverse tan 2/3. Okay, just using that formula. So you can see our question is nice and easy now because inverse tan and tan will cancel each other. So we've actually got 5 minus inverse tan and tan inverse functions. And 1 plus, again, this one will be 5 times, I'll put in brackets, 2/3. So you can do that in your calculator, but you should get a 1 for that one. 13 on 3 over 13 on 3. So we know the answer to that is 1. So if I come back here, let's go like, get rid of as much as this. And I'll just put a little 1 here. Okay, so that is equal to 1. All right, hence write z in the form x plus iy, where x and y are real. All right, so if we think about what z is, it's a complex number, so we really just need the length of it and the argument of it. And it's talking about, oh, sorry, did I not finish this question? I did not. And hence find argument z without finding z. Sorry, let's go back to that. So arg z without finding z. Whew, okay, so arg z, again, we don't want to use, so arg z, we know z is made up of z1 on z2, so that is the same as using our properties arg z1 minus arg z2. What's the argument of z1? Well, where's z1? z1, oh, is here, across 1 up 5. So we're looking for this angle here, the argument in here, if you can see there, just there's my theta. Okay, we're looking for the argument there. So we know, looking at this one, tan theta is rise on run, so 5 on 1 or 5. So the argument is inverse tan 5. The other one, Z2, is across 3 and up 2, if you think about it. So there it is there. So for that one, tan theta, I should call it theta 2 and this theta 1, is rise on run. So therefore theta 2 is inverse tan of 2/3. Hope that makes sense. So let's go back. The argument of Z1, which is theta 1, is inverse tan 5. And the argument of Z2 is inverse tan of 2/3. Okay, now that we can't do, but remember what we just did. We found, oh, it's up here. We found that tan of inverse of that same thing there is equal to 1. That's what we found. So what I could do is go tan of this arg z. So if I tan both sides, you can see I'm going to get tan of, and this is just so I can use what we've already got. Tan of arg z, there we go. And from the previous part, again, from this previous part in B, we already have that equals 1. All right, so we know that equals 1. So if I just want to find arg z, I can use that because I need to inverse tan both sides. So if I'll do it 1 step. So I'm inverse tanning tan arg z. And I'm inverse tanning 1. So inverse tan both sides. So you can see we've got inverse functions. So we're going to be left with arg z. And we know inverse tan of 1, or the tangent of a rise of 1 over 1, is pi on 4. So we know the arg z is equal to pi on 4. So I should have written that one equals 1. And this equals arg z equals pi on 4. Arg z equals pi on 4. So now we know two things about z. We know the length of z is root 2. So the length of z is root 2. And the argument of z is pi on 4. So I know z is root 2 cis pi on 4 in a kind of a clever way round without having to do z1 divided by z2. So hence it does say write it in Cartesian form, x plus iy. So if I just make a bit of room, now I've got that. Oops, got rid of the question, but anyway, Cartesian form, of course. Oops, pen. So that would be root 2 cos of pi on 4 plus I sine of pi on 4. So cos of pi on 4, 1 on root 2, cos 45, and sine of pi on 4, 1 on root 2, 1 on root 2 as well. So we've got a root 2 out the front and a divided by root 2 inside, so that's going to be 1 plus I. Hope that helps.